Wonderful. So what we're going to do is in just 2 or 3 minutes, I'm going to request some of the discussion leads to summarize what was discussed for the broader audience and for the online community, what was discussed in the in the internal smaller group meetings, right? And then following that, we will start with the next discussion panel. So okay. You can introduce yourself.
Thank you, Dr. Kaushik. So I am Ananya Mahanti. I am a postdoc here with Dr. Kaushik, Genesis Lab. So I was a co-lead with Dr. Anand Sahai on our small breakout group, the second breakout group that we had on privacy preserving techniques that we could adopt, or what are the concerns in and around that aspect of things. So what came out from our discussions broadly is that we all agree that privacy is connected to our human perception of modesty, and that it also has context and possible consequences of what could get harmed if it's violated. And we tend to agree that possible allowances could be made for data usage for the purpose of research and education, where we have a fair use kind of allowance for data with respect to privacy concerns when it relates to education and research. Second, it was privacy's definition itself may be different in the context of data aggregation, which means that data collected from individual entities may not be that much of a concern, but if you aggregate a lot of that data from multiple users and then we do our computations on the aggregated data, that could be potentially a problem, and we could be inferring things that we would not have been able to before. So that's one aspect that we have discussed. Another one was what would be the least kind of level of privacy protection that we would consider, or in terms of, especially in terms of unintended access to information. Say one example which came up in the discussion was if we are going through a neighborhood and we see the access points coming up on our phone, the number of access points, we could make certain deductions about the socio-economic factors in the neighborhood. That is probably it's broadband rich, or multiple people have tech savvy, but those are also information that we did not intend to sniff, but we just got it from the perspective of just a naive user trying to connect to a Wi-Fi access point. So one strong point that came out from the discussion was more clarity on the rules as to what we can do, what we cannot do, and in terms of having access to website where we could possibly put in the use cases that we are looking to do, and then be guided to the specific rules that we need to follow with respect to that frequency band and that use case. To conclude this summary, one point was that not just with respect to the transmission itself, but also with the application layer, that there are concerns regarding malicious apps, what they're trying to do with the data that we are transmitting, or unlike photo sharing where we know exactly what we are sharing, we don't seem to know everything of all the information and identifiers that we are transmitting when we are transmitting RF signals. So in terms of that, Do we understand? Do we have better control over exactly the information that we are sharing, which I think some of the companies even now are trying to do and extend. So these are broadly the factors that we discussed, and I'd like to hand over to Deboshri, who is hosting the other small breakout group on the same topic. Thank you.
Hi everyone. So I'm Debasri. I am a research scientist with Kausik's lab. So I was in the other group, group one actually, in the breakout room, and it's about the same topic, the technical architectures for privacy protection in RF datasets, and we had quite an interesting conversation. So all of us, like whoever was present there, we all contributed to the discussion, and more than agreeing to things, we tried to find out what are the limitations. So what are the different things still we can do to improve it. So one thing, what the concern, first concern which came out was that what is the, like, how we can define how much data or how much how to estimate the privacy, like how much data breaching or how much we are okay with sharing with other people, right? So that we can label somehow now, but can we predict that for future? So there we need like a continuous continuous tune up of that, even that parameter. So that is one part. And then we were thinking how to come up with some rules or some best practices so that the user, like, so that the user will know how to use the RF data, right? That is another part. Because unlike the image and video or the audio, right, what Ananya was saying, it's harder, like it's very easy for us to know what is private and not private in an image or video. But in RF data, it takes a lot of time for us to do the signal processing and to know which data are actually private information, right? So how to streamline that thing as well. So these are different concerns. And then the ML system came into play in the discussion. So then the ML people started to talk that this neural network thing can may help to solve the problem. So how can we build a ML system which will do the things for us? So we don't need to specifically set the rules, or we don't need to specifically find the violations ourselves. So maybe we can design an ML system which will find the violations itself, right? So there is a artificial neural network, so the data privacy is not being breached. But for that path, so again the concern came that how to do the learning, like how to do the training, how to find out the labeling, how to label those data for the training. And then what if we have the false negatives, how to deal with those? So yeah, so those are the different research problems we need to solve if we go with that path. Then we are thinking if we can build some rules which, like, interdisciplinary domain of security, privacy, and law, and the wireless communication. If these two domain can be merged together, and which will kind of supervise or kind of intervene into this privacy, help the wireless community to help preserve the privacy issue, like to help preserve the private data. Then the other thing was that if we can have a streamlined IRB process to review the data collection, collecting data collection in the NRDZ, this national radio dynamic zones, like collection in those zones. Then Kausik had an interesting insight. He said, like, can we create MNIST level, like the image community, the vision community, they have MNIST. So can we create our own MNIST somehow, like for different, like it could be something with IQ, which is fully vetted, fully private, and and then something with spectrograms maybe, which and people can use it, the industry people and also the academic people. And we also had some insights from the industry people, and they were mostly concerned about how the authenticity of the data, which we the academics we publish for free usage. Now, for them, it's like which kind of hardware we use, they are not being used commercially, right? So how they can rely on a machine learning algorithm which is being trained on our data and then apply it commercially later, which like you are using completely different hardware system. So that is another interesting concern. Then we talked about some of this reproducibility of results, or like reproducibility of results in the different academic papers. And on one point, we also talked about how we can create like data servers where we have like we go there and don't still take out the data, but there are different concerns about them as well, how to, whom to enter, whom to let use those data servers. So I think overall we actually argued and we actually raised a lot of concerns, which as like community, industry, and academia, we have to solve a lot of problems to come to an agreement overall over privacy for RF datasets. Yeah, so that's all.
Thank you to the discussion co-leads, Anand and Devashi, for really summarizing the discussion very well. So let's